In this video, we're going to take a look at the quotient rule. And the quotient rule is used to find the derivative of the quotient of two functions. So the rule says that the derivative, this is the derivative of one function f of x divided by another function g of x is equal to this rule. So let's take a quick look at the rule. If you look at just the numerator, it looks a lot like the product rule. In fact, it is very similar to the product rule. So if you've memorized the product rule, the only difference is right here we have a minus sign rather than a plus sign. Okay, so the product rule, it was f prime g plus fg prime. Now it's a minus. And then the other big difference is that it has a denominator where we take the function g of x and we square it. So as always, let's just get right in and do one example. So when deciding what the numerator is and denominator are going to be, that's pretty easy with the quotient rule because the numerator right here will always be f of x. And the denominator will always be g of x. So just like with the product rule, let's start by writing out f of x and its derivative, f prime of x, which in this case is just 3, and g of x, which is 5x minus 4, and its derivative, which is 5. And then let's put it together in the formula. So the formula says that y prime is equal to f prime g minus f g prime all over g squared. So that's going to look like 3 times, that's f prime, g is 5x minus 4, minus f, which is 3x plus 1, times g prime, which is 5. And all of that is being multiplied by g squared. So we have 5x minus 4 quantity squared. And don't actually square that, just leave it written as 5x minus 4 quantity squared. Well, now we just need to simplify a little bit. So let's clean up the numerator. We can distribute this 3 and we can distribute this 5. So 3 times 5x is 15x. 3 times the negative 4 is going to be minus 12. Then we have 5 times 3x, and that's minus, so that's minus 15x. And then we have 5 times 1, and that's a minus 5. All over the denominator squared, which we are not going to square once again. And then finally, these two terms cancel out, so we end up with a negative 17 over the denominator squared. And we can leave it like that. There is our derivative. In the next example, somewhat similar to this one, the numerator will become our f of x. So f of x is 3x squared minus 5x plus 2. The derivative of that will then be 6x minus 5. G of x is the denominator, 2x squared minus 3. So g prime of x is 4x. Now we want to put it together in the rule. Y prime is equal to f prime g minus f g prime all over g squared. So that is going to look like f prime 6x minus 5 times g, and g is 2x squared minus 3, minus f, which is 3x squared minus 5x plus 2 times g prime, which is 4x. And all of that is divided by g squared, which would be 2x squared minus 3 quantity squared. So there's a lot of simplifying going to be going on here. I'm going to move over here a little bit. So we can multiply these two binomials together. So we have 12x cubed minus 8. Let's go in order. So we have minus 10x squared minus 3 times 6 is 18x and plus 15. Then multiplying this 4x by this trinomial, we will have 12x cubed, and this is all being subtracted, so I'm going to put it in a big bracket. 12x cubed, 4x times a minus 5x is minus 20x squared, and then 2 times 4x is 8x, all over the denominator squared. And once again, don't actually square that. So next step, let's see. We're going to distribute this negative, which is going to change all of these signs. So we have a 12x cubed here, and this minus 12x cubed will cancel out. They go bye-bye. We have a negative 10x squared, and then this minus this negative will be plus 20x squared. So plus 20 and minus 10 would be plus 10. So we have 10x squared. That takes care of that term and that term. Negative 18x minus 8x would be negative 26x. That takes care of that and that. And then we just have the plus 15. And that is over the denominator squared. Oops, that's a 3. And there we have it. That is the derivative. As simplified as we can get it. Okay, in the next one, once again, f of x is the numerator. So that's the square root of x plus 1. And its derivative, well, the derivative of square root of x plus 1 is 1/2 x to the negative 1/2, and the derivative of 1 is 0. So this then becomes 1/2 square root of x. I'm not sure which form we want to leave it in, so I'm going to have it in both. And then g of x is the square root of x minus 1, and it's going to have the same derivative because the minus 1 plus 1 are the only difference, and they just become 0 anyway. So this is 1/2 x to the negative 1/2, or 1/2 square root of x. So y prime is equal to f prime g minus f g prime all over g squared. Let's see what we get here. F prime is 1/2 square root of x times g, which is the square root of x minus 1, minus f times g prime. So I'm just going to switch the order of those. I'm going to put the 1/2 radical x. That's my g prime, times f, which is the square root of x plus 1, all over the square root of x minus 1 squared. So this is going to take a little bit of simplifying here, isn't it? So multiplying 1/2 radical x times the square root of x, well, the square root of x's cancel out, so I simply get 1/2. Then minus 1 times 1/2 radical x is minus 1/2 radical x. That's the first term. And in the second term, we have minus, these are going to cancel out, so I'm going to have a minus 1/2. And then minus this times the plus is going to give me a minus 1 over 2 radical x again, all over the square root of x minus 1 squared. Well, these cancel out, and these two terms are similar terms, so we can combine them. And so we're going to end up with a negative 2 over, because we have common denominators, we have fractions. And so with the fractions have common denominators. And so we can combine the numerators, which we would get minus 2 over 2 radical x all over the square root of x minus 1 squared. And then these 2's cancel, so I have a negative 1 over the square root of x. And let's take care of this denominator. That's not underneath the radicals, times the square root of x minus 1 squared. And almost done. Let's move off to the right here a little bit. Let's simplify this. This is a complex fraction. This is all over 1. So we're going to take the numerator and multiply it by the reciprocal of the denominator. And so we're going to have negative 1 over the square root of x times the square root of x minus 1 squared. And we will just leave it like that for now. That would be our derivative. The next problem. We have another radical in here. And so f of x is the numerator. And so that is x plus x squared. The derivative of that, f prime of x, is 1 plus 2x. And I'll do a g of x over here. G of x is 2 square root of x. And so g prime of x is, so the square root of x, once again, is, so this is going to be 2 times the square root, the derivative of the square root of x, which once again is 1/2 x to the negative 1/2, which then becomes 2 times 1 over 2 radical x. Those cancel, so I end up with 1 over radical x. And so putting it together, y prime is equal to f prime g minus f g prime all over g squared. So f prime is 1 plus 2x times g, which is 2 square root of x, minus f times g prime. And so f is x plus x squared times g prime was 1 over the square root of x all over g squared, 2 square root of x, quantity squared. So multiplying these together, 2 radical x times 1 is 2 radical x. 2 radical x times 2x would be 4x to the 3/2. And then 1 over radical x, multiplying these, 1 over radical x times x is going to be x over radical x, or radical x. And then x squared times 1 over the square root of x will be x to the 3/2. And I'm just using my exponent rules now. And then all of this is over. Now, this is just a monomial, and squaring it gives me 4x. Okay, so this term and this term can be combined. I have 4 plus 1 is 5x to the 3/2. And then 2 radical x plus radical x can be combined to give me 3 radical x. Or I'm just to be consistent, that's the same as 3x to the 1/2. and that's being divided by 4x. Well, now I can factor an x out of the numerator. We can factor the lowest power of x out of the numerator. So x to the 1/2 can be factored out, leaving me with 5. So x, that's going to be x, and 3 is what's left over there. And then 4x. And so this x to the 1/2 can cancel with part of that, leaving me with then square root of x. So I have 5x plus 3 over 4 square root of x. A lot of exponent rules, a lot of converting between rational and exponents and radicals, but we've been doing this for a couple of weeks now, so you should be getting pretty good at doing that. Okay, I want to move on to doing one that has an e in it. So the numerator, f of x, is e to the x, and the derivative of that is e to the x. The denominator, g of x, is x, and the derivative is 1. And so putting it together, y prime is equal to f prime g minus f g prime over g squared. We have f prime e to the x times g would be x e to the x minus f, which is e to the x, times g prime, which is 1, minus e to the x. All over the denominator squared would be x squared. And so not much we can do to that. We could factor an e to the x out of the numerator, common factor of e to the x, leaving me with x minus 1 all over x squared. And here's one with a logarithm. So the numerator is e to the x, and its derivative is e to the x. The denominator is the log of x, and its derivative is 1 over x. So y prime equals f prime g minus f g prime over g squared. We're going to have f prime is e to the x times g, which is the log of x, minus f, which is e to the x, times g prime, which is 1 over x. And that's all over g squared, which is the log of x squared. And so now we want to clean up the numerator. I can factor out an e to the x in the numerator. And I'm left with the log of x minus 1 over x divided by the log of x quantity squared. All right, now we can't leave this as a complex fraction. So we have 1 over x, which is a fraction, in the numerator. Therefore, this is a complex fraction. So what I'm going to do is the denominator of this fraction in the numerator is an x. I'm going to multiply the numerator and the denominator by x. Whatever this is down here, I'm going to multiply by that. What I'm then going to get then is in the numerator, I'm introducing an extra factor of x. And so I'm going to get, I'm going to multiply that through here. So I'm going to have x log of x minus, and we multiply that x times the 1 over x minus 1. And then in the denominator, I'm going to put that right here. So it's slash, we're going to have an x log of x squared. So what I did was I got rid of the complex fraction. And one more. So we have the log of x is f of x. Its derivative is 1 over x. G of x is e to the x. So g prime of x is e to the x. So y prime is equal to f prime g minus f g prime all over g squared. So we have f prime is 1 over x times g, which is e to the x, minus f, which is the log of x, times g prime, which is e to the x, all over g squared, which is e to the x squared. And so we have the x in the numerator. In the numerator, we have a 1 over x again. So it's this little x. So I'm going to multiply now. I'm going to do it a little bit earlier in this problem. Multiply the numerator and denominator by x. And so what that's going to give me is multiplying this first term by x. The 1 over x times x goes away. I'm left with just e to the x. And then that's going to be minus x log of x e to the x all over x, and then e to the x quantity squared is e to the 2x. And then finally, factoring in e to the x out of the numerator, we get 1 minus x log of x all over x e to the 2x. Oh, and we can do one more thing. We can do a little canceling here, because we have 2 e to the x's in the denominator and 1 in the numerator. That cancels with one of these. So we're just going to end up with 1 minus x log of x all over e to the x. All right, and that is the quotient rule.